Welcome everyone, and thank you for taking the time out of your day to join us for a webinar covering thermal imaging technology and how it helps keep mines safe and productive. My name is Christopher Winbun with Teledyne FLIR, and joining me from BCB is Noam and Francisco, who will be guiding you through the presentation today. During the webinar, if you have any questions, please use the question pane that's been superimposed on the right-hand side of your screen. You can ask any questions during the webinar, and at the end of the presentation, we will take time to answer those questions live on the air. Now I invite you to sit back, relax, as we are about ready to get this presentation started. Noam, over to you.
Hello, everybody. Thank you a lot for joining this webinar. I hope it's going to be useful for you. And well, thank you also to FLIR to give us the opportunity, the trust that they have placed in us so we could deliver this very interesting webinar. Our company is called BCB. We are experts in thermography, and I will show you first of all the schedule. So we're going to talk very quick about BCB. Then we're going to talk about some applications. It should be very interesting for you. Then after that, we're going to head to a demo, hotspots detection, the solution of Teledyne FLIR BCB. And at the end, we're going to have some minutes for answering to some questions and answer. Thank you very much, and let's start. So let's talk about very quick about who's BCB. Who is BCB? Well, BCB is a technological small and medium company. It was founded 27 years ago in 1996. We already have 2 patents. We have been monitoring more than 1,000 cells of copper and zinc, and we are present here in Spain, which is our headquarters, and in Mexico since 2012. And we are proudly to say that we are key industrial partners of Teledyne FLIR. About the technologies which we dominate during all these years, it's data acquisition, machine vision, and big data, which mostly we have been focusing during the last years in machine vision, talking about the Teledyne FLIR cameras, the thermal cameras. Okay, so a good example of this is of the gathering of these 3 technologies is the BCB monitor, which we're going to talk about a bit more at the end of this presentation. About our references, BCB has a wide solution portfolio for practically every single sector, like automotive, energy, mining, aerospace. Right now in this webinar, we're going to be focusing in mining and metallurgy. So maybe it comes to your mind these big names like Peñoles, Grupo México, and also a Glencore, which are really big companies that participate in the mining sector. We have been having really good works with them, really good applications with the mining sector, and these are the clients that have trust in us. About our differentiating factors, we have quality and security standards, which we are working with ISO 9001 quality certificate since 2003, and also we have been named key industrial partner of Teledyne FLIR due to the exceptional thermographic automation tools we have delivered to different types of industries. This one, which you are seeing right now in the screen, it's an application note which we delivered to a client, a really complex solution, and we're very glad that at the end everything went well. And I can tell you that for your application, for your need, we for sure will have a solution. So now my colleague Francisco Escobar is gonna take the lead. So please, Francisco, jump in and let's talk about mobile equipment inspection solutions.
Thank you, Naum, and thank you everyone for joining us. Let's talk about a little bit about mobile equipment inspection. One of the most common elements in mining are the motorized vehicles as trucks and shovels. That's why the importance of keep them in optimal condition. Here are some example of applications. Truck tire inspection. The inspection of the tire is really important. Why? Because even a small injury by the time can be converted in a large damage and leave the truck out of operation while the tire is changed or fixed. Or even worse, it can damage the truck itself and this affects the production of the mine and have safety and monetary repercussions. With the thermal cameras, we're able to monitor the tires 24/7 and detect tire wear or injuries in form of hot spots as the ones we are seeing in these pictures. For example, in the one in the top, with thermography, it's possible to see the wear that cannot be seen with naked eye. And in the other pictures, we see hot spots in the tire. We can inspect the vehicles either in the mechanical workshop or even moving during the operation. Also, the system has the capacity of recognize the truck and the specific tire that is damaged. This is so important because with the RFID, which is recognizing of every mining truck, the system sends the alert to the operator with all the information. So the operator can detect which truck has the problem, remove it, and fix it on time, which is possible to prevent a lot of accidents and keep a continuous production. Another important application is cooling system inspection. This is the monitoring of the radiator. With thermography, it is possible to see the temperature changes in the radiator and any obstruction that might exist and affect it. One of the main challenges in this inspection is that generally we found a fan rotating at high speeds between the area where the camera can be placed and the radiator, just like the regular vehicles that you have at home. So how we work with this? We use a cooled camera that is a camera capable of capturing images at high speed. As you see in the picture, in the right one, it looks like the time is stopped and it seems that the fan blades are not moving. This is because of the very low acquisition of this camera. Here we have another example of this. In the left picture, we have a turbine blades or a thermal power plant. Despite of the RPM of the turbine, the camera is able to capture the image of the blades, and you can see them in a slow motion. And this is really useful if we want to see the fan or the objects behind it without any blur. In this case, it allows us to see the radiator and detect internal variation. Also, in this same area from the top, we can inspect another elements. Like in the picture over here in the right, we are seeing in one part the radiator, and in the other area, we have the fan shaft. We can monitor the temperature over here, and if there is a normal temperature, we alert and send to the operator. So far, we have been seeing application for trucks. For the shovels, we monitor the PTO, the power takeoff system, and send a daily report. Why we send the report just once a day? Well, this is because the ability of the bandwidth, and this report can be video, a writing report, or images. But also, we can send an alarm signal if there is a critical element with thermal malfunction, and this can be at any time. In the PTO, we have a lot of elements, right? So what we do is selecting the critical element with a ROI, region of interest, and we set a lower and higher temperature limit. And with this, we create an alarm. If something goes up or down, we send a notification. This consumes just a little bit of the data, and we can send this every time that happens. Inspection of conveyor belts in operation. Inspection of belts or conveyors. One of the most important and helpful elements for mining process is the transportation of mineral through conveyors. The transportation of this mineral is required continually, and stop it can affect the production of the mine. The belt is a critical and one of the most costly components of the conveyor, and any damage to it can result in long, unexpected stoppages of production. This is why it's very important that the belt is inspected frequently. And in addition to the delays in production, which affects the mine's goals and has monetary repercussions, also represent a safety issue. But this is one more reason to inspect it. For this inspection, we use high-speed cameras. Previously, we talked about the importance of acquiring images at high velocity when we want to analyze an object that moves faster than normal. So, for this application, we use a cooled camera, and with this, it's possible to detect discontinuities even with the belt working normally. This is so important because, as we said before, the continuous production in mining is crucial. Some discontinuities that the system is able to find are cracks, agglomeration, attachment, and exposed and broken cables. As we see in the GIF on the left, the bell pass at high velocity. So we analyze these images by frames, as the one imagined on the right, and detect discontinuities as the one marked in red. To inspect the bell, what we do is place the camera at one point, like the one we see in this picture, in the point 1. Then we inspect the entire face of the bell by sections, and we detect which discontinuity is found and in which section. Once we finish the first inspections, we do the same on the opposite face of the bell by placing the camera towards the opposite side so we can examine the entire section in the same way. Once we made the inspection of the bell in both sides, the system generated a report with information of the discontinuities by sector. This information is very important to determine when to perform maintenance, avoiding unnecessary stoppages, and most important, the report informs when the bell is very worn or has many discontinuities and emergency maintenance is required. And all this helps to extend the life of the bells and avoid costly expenses to the damage and time out of operations. Here's an example of the report made by the system and some of the discontinuities that we can detect, as you must see in section A, B, C, or D. It's very important to leave this analytical task to the system that give the result automatically. Why? Well, since inspections cover up to 70 kilometers sometimes, imagine all these informations in the half of an listing. It will involve many hours of work. So with this automatic system, you can do it so much faster and leave the workers do another work. Mill inspection in operation. One of the main and highly important elements is mills. With thermal cameras, we can monitor them without the need to stop production. We know that such shutdowns are costly. Therefore, all the checks can be carried out without interrupting the operation of this equipment at any time. We primarily focus on analyzing SAG mills and ball mills. In the case of SAG mills, we can analyze the ball per section. We have high-speed cameras with which we can analyze each of the poles and determine if there are any temperature discontinuities in any of them and in which one specifically. In addition to this, we can also determine temperatures and detect thermal discontinuities in the pinion gear section. This is for both, for SAG mills and ball mills. As we can see in the image below, we precisely monitor the temperature along the mill shell and detect any thermal changes. If this occurs, we can promptly raise an alarm. In addition to this, we also inspect the liner seal, both at the inlet and outlet, by placing a camera that inspects this seal, checking the temperature it shows. As we can see in the image below, we precisely monitor the temperature along the mill liner and detect any thermal wear. This inspection is possible with a single camera and software. Well, what do the software? The software analyze these images and make a scanning of the area so we can see all the 360 degrees. In the area of the shield, also we can inspect the pins. You might ask, how is it possible to analyze a pin when they are rotating at high speeds and the side relative to the shield is small? Well, what we do is precisely what we talked about earlier with the cool camera. We can see how the pin passed by, and even at normal speed, we could notice them. With high-speed cameras, we can slow down the time and view it at a fixed moment, as we're seeing right now in these images. Now, in this video, we're saying the same operation, but with a little bit more speed.
Thank you very much, Francisco. Those application was very, very interesting. Now we're going to pass to the next application, which is about the hotspot detection in electrolytic cells, which interestingly, we have a lot of experience in this software. This is probably one of our most solid software, as we already have 8 years of experience with this system. About the BCB electrolytic IR with the FLIR thermal cameras, which are the main cameras that we are using here. What is it? So the BCB electrolytic IR is a monitorization system which has been specially elaborated for the electrolysis or electrowinning production process. This software monitors the temperature of the anodes, the cathodes, the cell feed pipes, and the overflow boxes areas, and provides to you, to the operator, to the user, with a customized alarms for the final user to take decisions or study its process and temperatures. It's very important to say that this is not only a software which is built once as we think it's going to work, no, but it's it's very flexible software for being tailored to any application of this type, like electrolysis. If you need to be this application to be placed in a server, to be placed in a web server, it's totally possible. So it's important for you to know that this is very flexible software, and this can be installed as you wish. So why is it important, the special housings for these cameras? Well, as you probably may know, the electrolysis and electrowinning process is not very friendly atmosphere where this process is being taken, is being done. So we need these special housings for being sulfuric acid resistant. That's why we along these years have been discovering, and now it's very clear that we need these special housings for this application, and this is not longer a problem. And now about the visible electrolytic, the interface, as you can see here, you can have 3, 4, 5, as many lines as you wish for the measuring, monitoring, and the study temperatures of your production process. As you can see here in this screen, you can see that we have our interface, the one in the middle, and you can check live with the temperatures of all the line, of all the cells, and also your overflow boxes. Also, if you would like to add more region of interests in these areas, you can add them, and you can place a specific alarm for every single region of interest to your lines. Also, at the top right part of this screen, you can see the graphs, which are the historics of every single overflow box or every single cell in which we are monitoring, and we are placing here the temperatures. You can check the historics, you can check the temperatures 1 month ago, 2 months ago, and you can check which is the normal temperatures of your process, and you can set alarms. So we can check if there's any short circuit. You can place a customized alarm for every temperature. So this is very important because as we already have had experience, lots of years of experience in this type of software, now, as you may know, for predicting, for using machine learning techniques, we need a lot of data. So you can now use this new tool which we are now developing, that is the prediction of short circuits that can happen after some behavior has been developing along the time. So this is now something that we are working now with some clients, and that right now we are developing in order to deliver this add-in to our next clients. Now, let's talk about the electrical systems monitoring. You can see here there's some elements that are very important for every single industry. So some of the most important elements in, for example, the steel production industry or the zinc production industry are substations, the transformer rooms, the critical enclosures, or the electrical motors. These are not only important because they are essential for the production process, but also because they are very expensive if there's a failure. That's why we offer, probably for you would say, okay, I just need one fixed camera to be monitoring this area for or this motor or this transformer or any critical element for your fabric. But also you would say, okay, I need to monitorize in one room several elements. So we can place a camera in a pan tilt, and we can make like these routines for checking several elements inside the room that you want. And also one of our latest and most let's say, complex solutions we have developed and probably went very well is this robot that you can see right now in the screen. This robot has 4 cameras. It's the visible camera, the thermographic camera, and the OGI camera for detecting gas like SF6, and also one that detects the corona effect, which is the ultraviolet camera. So 4 in 1, that it's placed, 4 cameras that are placed at the top of the pan tilt, and they are moving also in a substation, which in this application we use this robot. We placed the robot in several parts of the substation, and then the pan tilt pointed the 4 cameras for detecting several for measuring several parts of a transformer, for example. And along the year you can check those that information, and you can check which is the normal and temperature of operation of your elements. And then we are now using this new application, which we have been developing along FLIR, which we are now using the Flex View lens, which is ideal for the pan tilt substation monitoring. For example, here you can see that, I don't know, we place a camera at the top of a pan tilt, we point to some part, and now we check that there's a really hot spot, and then we make a zoom in. So you go from 24 degrees to 14 degrees, and you check and confirm that there's a hot spot there, and it's a possible there's a possibility that there's probably an accident there, or it's gonna be dangerous for the substation. So this is now possible, the new Flex View lens. Now let's talk about the demo time. We have prepared a demo with our colleague Edward. So please, Edward, jump in and show us what you have prepared. Thank you very much.
Now we are going to observe a functionality demonstration about the software BCB Electrolytic IR for the hotspots detection. As we mentioned previously, a thermographic camera can detect hotspots in electrolytic cells. In this case, we have a series of electrical resistances making a simile of electrolytic cells. Now, I'm going to short circuit some resistors, and we will see how from the first second the resistors that are shorted will be seen as hot spots in the thermographic image. In this way, by placing a temperature alarm in the software, we can know if there is a potential short circuit by receiving an alert to any device interconnected to the corporate network. Here we are seeing how 3 resistors have a hotspots that could cause a possible short circuit, which is evident just by looking at the color scale or even analyzing historical process data. And as we can see, it can be noticed in the visual image. And also, if we put a region of interest in each hotspot, we can notice how the maximum temperature is increasing second by second, or even the minimum, average, or maximum temperature of just one region of interest. So that's a small demonstration of how the application works for detecting hotspots in electrolytic cells. Let us now continue with the next topic.
Thank you very much, Edward. It was a very interesting demo. As you can see, we were using a software. This software is called the BCB Monitor 4.0, which you saw there, the user interface. So actually, this software was developed for using FLIR cameras. So together with these FLIR cameras, the BCB Monitor would become for sure a very powerful tool for any industrial process that you would have. If you would like to know more about, please send us an email. And we would like to thank you a lot. Thank you very much for your time. If you have any questions, we are going to pass now to the questions section. Here in this last slide, you can find our email from me, the project manager director here in Spain and in Mexico. It's naumjaime@bcb.es, Jairo Garcia, bcbmex.com, and our LinkedIn. Thank you very much for your time, and let's pass to the question section.
Wow, Noam and the rest of the BCB team, I want to thank you for an excellent presentation. We do have some questions that are already coming into the question pane. Before we get to those, folks, just real quick, if you joined a little bit late, there is a question pane that can be accessed from the GoToWebinar Council. If you do have any questions, now is the time to get those into us so that we can answer them for you here on the air. I'd also like to point out that in the GoToWebinar Council, there are also handouts that you can take with you after the webinar. So you can download those, take them with you. If you're looking for them after the webinar, feel free to go ahead and reach out to us. We'll make sure that we get those to you. I'm going to go ahead and answer one question that always seems to come up whenever we do a webinar. Will there be access to this presentation afterwards? And the answer is absolutely. We do record all of our events and we can make them available to you after the webinar. So anybody who has joined the webinar or who has registered for the webinar will receive a recorded copy shortly after the conclusion of the event. So what I'm going to do is I'm going to turn my attention over to the question pane right now. We'll get started. And of course, folks, remember, if you do have questions, go ahead and funnel those in at this time. The first question that we have coming in is in regards to the electrolytic system. And the question is, can this system be integrated into the security system of a plant?
Hello, do you hear me there? I think you can hear me, right? So
Yes,
about
sir.
the integration of in the security system, yes, it's totally possible. Actually, we have developed this tool for being, as I said, completely flexible. So whether if you want to have it like isolated, the system, you can have it totally isolated, or you can integrate it to your system. You can send an alarms, SMS. You can send an email. You can do whatever you want. You can connect it to your PLC. It's completely flexible. So yes, the answer is yes.
Perfect, perfect. The next question that we have is, are all of the analytics shown in the presentation integrated into the FLIR cameras, or do they require a computer with software?
Well, about this one, well, the cameras actually can provide with analytics. As most of them, or actually, yeah, we can say most of them are like the basic analytics. This is why we developed this software, and actually it's not only a software, it's a whole system in which it will give you not only the temperature, but it will study whether there is a potential, talking about the BCB electrolytic system, it will help you to have a historic data. It will provide you with tools, and also to your operators, it will provide you with many other calculations, so that are not included in the camera for sure. But this system completely with the FLIR cameras, with the engineering behind it, with the software, it becomes a very complex system that will help you with give you the best and the most important data for which is also customized. Also, it can be customized for you. Whether if you would like to have the data in your PLC, it's totally flexible, and I would say yes. Like the software we developed gives you more data than the camera. The system gives you more data than just the camera.
Excellent, excellent. All right, I'm going to get back up here to the top of the question pane. I do have a question in regards to calibration. So how often do you have to calibrate? So I don't know if that's specific on the camera or the analytics. Maybe you can add a little context to it. And Kevin, that's your question there. If you want to add a little bit more detail for us to answer that, that would be great. But no, any information that you can share with us in regards to calibration.
About calibration, what we normally do is maybe, I mean, calibration is part like part of the system. Let's say maintenance. So we normally calibrate it automatically once every single month, because as this is a system which we are in charge of giving the maintenance, which includes the whole package, we connect remotely to the software. We realized a whole maintenance system, and we calibrate the cameras also once every month. So yes, we do calibrate, and we make because of course it's very important that they should be calibrated, as we are giving to you a security system. You know, this is part of a security system. Not only it is also like you can study the temperatures of your process, but it is very important that these temperatures are real. So yes, we calibrate it.
Excellent, excellent.
Also, there it depends of the using of the system. Sometimes you use more in I mean, the temperature is very important. In this case, you must calibrate the cameras one time per year, and FLIR does it with black bodies. But other times, the temperature is not so important, and is perhaps is enough to calibrate every 2 years, or you can increase this time also.
Perfect, perfect. We've got another question about integrations. And the question is, have you ever integrated your substation monitoring thermal camera with acoustic ultrasound systems? And this would be for monitoring like corona partial discharge tracking.
About corona, normally, if you speak about acoustic ultrasound systems, for example, FLIR has a system, but it's manual. We try to integrate in automatic way. So in this moment, the integration is a little is not complete. So we prefer using corona cameras that the integration is easier.
Okay, we've got another question about what the cameras can detect. And this one is, can the cameras detect or give indication of chemical changes to materials?
I can help you with that, Chris. Yeah, it is possible. For example, in the electrowinning process, there is a chemical change, and also the camera can detect, no? Because it depends if the chemical reaction has an exothermic exchange, no? So it is possible, and also you have to consider that all the FLIR cameras has a very good thermal sensitivity. We are talking about 0.05 Celsius degrees. That is a very big difference between the change of a thing, no? For example, in leaching process, all the thermal changes having place in the surface of the tank are very clear for the camera, no? Also, another good example is on the pit. You can visualize, you can display with the camera for example, humidity zone, for example, and all those chemical changes can be very good examined by the camera. So yeah, it is a good question. In fact, that's the interesting thing of the cameras, not that can analyze and supervise these changes with a very good resolution.
Also, it's possible to detect gases using OGI cameras. So, for example, we are able to detect CO or CO2, SF6, that is very important for electric issues, and also hydrocarbons. For example, we are working in solar power plants, and we detect liquids produced in the tubes that have hydrocarbons. So these OGI cameras are also very important in the industry.
Excellent, excellent, guys. Thank you very much. We've got one last question in the question pane here, and then we'll begin to start wrapping things up. This question is in regards to specific to the mining industry, right, and the harshness of the environments. And the question is, are the cameras resistant enough for those types of environments?
Of course they are. But this is important to mention. No, the camera, almost of the FLIR cameras has the IP66 degree. This is very good. No, the camera will resist these conditions, but it is important to mention that the lens will not be covered in the case of a dust, or for example in the lubrication zones. There are a lot of splashes about or mist, and the lens will not be covered in this case, and if it's affected, the measurement will be incorrect. No, so in these cases you need an additional protection, for example, to cover the lens, or also an air curtain. So we are in BCB have a lot of experience in protection systems. This helps to assure that the camera will have a continuous measurement without obstacles, without any dirty or things. You know that in a mining environment, if you not cover something, you will have a rock in a couple of days. So it's very important, the protection thing. You can refrigerate the camera, you can protect only the lens, or also if you have to cover the body, it's possible. So please reach at us to have a complete solution about the protection of the physical part of the camera. This is important, and it's very possible. There is no limitations for the thermal systems in mining.
If you want to use cameras with high ambient temperature, for example, with 300 degrees centigrade degrees, it's important to use housing and to cooling this housing with water and with air. For example, we have experience in ovens, and also, for example, we have experience in solar power plant receiver in towers with an ambient temperature of 200 or 250 degrees. So housing and the cooling of the housing is very important.
Excellent, guys. Hey, listen, I appreciate it. It looks like our question queue is clear for the time being. So this looks like a good time in the webinar. Let's go ahead and get things wrapped up. Folks, I appreciate your time today. A special shout out for the team over at BCB for an excellent presentation. Thank you for coming on and doing this with us. One quick thing before everybody leaves, we do have a survey on the exit of the webinar. We do appreciate the time that you spend with us, and we loved any feedback that you can share with us about the presentations, just to make sure that we continue to get content out there that really matches what you're looking for in the industry. So again, thank you everybody. Thank you for taking time out of your day to join us for this webinar, and have a great rest of your day.